Right. So today the plan will be we'll try to finish the state pattern. We only introduced to you the problem last time. Okay. The problem basically is whenever you want to solve some interactive system. So the one we're going to go over today for the illustration purpose, it will be some flight control system. Sorry, like flight reservation system. Okay. But any interactive system will be applicable. Okay. All right. Basically, we walk through this state transition diagram. So that's something we're going to use as a design principle. Okay, you got a state transition diagram here. And then the challenges will be you may have a large number of states and also very complex transitions. Okay, as we said. Okay, the first solution that we look at, okay, basically is only for illustration of a very poor design. You will only choose design number 1 if you only got an assembly language to program in. But I don't think that's the case usually. So for design number 1, we can just go very quickly. Let's go to design number 2. So that should be the focus to criticize. All right, so let's go to design number 2, which is a hierarchical design. Okay? It's going to be different levels. I'll explain that. Okay? But for both the design number 2 and the eventual state pattern, they're going to make use of the transition function over here. That's basically to encode the transition function. Okay? So now let's say, for example, let's say this. We have a table over here, as we explained last time. Just say very quickly. Okay? You can see this particular transition table. Let's say I'm currently in state number 3, the seed inquiry over there. Right? If in state number 3, I want to take action by choosing number 2, what would be the resulting states? It would be 2. Okay? So that means you got to say transition 3 and then 2, and the return value should be 2. Okay, that's something we said last time. If you're not uncomfortable about it, you can review the lecture from last time. Okay, and we can use a 2D array, let's say, or an array of array for the transition function. Okay, so what we will do now is to talk about this particular design. Okay, this design here, I can tell you, is a very good case study to compare between non-OO and OO design. Okay, we're going to see exactly how they can compare to each other. What we will see is we got different levels over here. Okay, so now what I want to do is to explain to you a little bit overall what you can expect. And then we'll talk about each level in details. Okay, over here. Okay, let's go over big picture. So it's called top-down or hierarchical. Okay, you can think about overall you just have a main function or main method over here. And then the main function there has different stages. You got initial, you got transition, you got execute states, and also you got is final, right? You got 4 different stages. Okay, we're going to look at each stage in detail. And also for this particular one, execute states. It simply means depending on what my current state is, I'm going to do different actions. Okay? For every state, I'm going to somehow display the current state information depending on where I am. Maybe I'm now trying to confirm the seat, or I'm trying to make an inquiry about a seat, right? Depends. And also I'm going to read in some input from the user. It can be credit card number. It can be maybe their membership number for the reservation, right? And also correct means validation. You want to do some validation on the input. And then output some error messages if necessary. And then eventually you're going to process to see what the user's choice is and then go to the next stage. Okay, that's kind of the big picture. But before we can criticize on this particular design, I would like to go over some code with you so we can talk about it. And keep in mind, this solution here is not OO. It's not, okay? So that means if you use C, for example, that could be a reasonable design if you have no OO. Okay, so what I will do is I'm going to present to you some code, and then we'll talk about the iPad. Okay, let's talk about the first one. So let's talk about the top one, execute session. You can think about this is the main function, main method. Okay, let's go over line by line quickly. So now, first of all, I want you to pay attention to the local variable we're declaring over here. You can see now for this particular execute session here, we have something called current states. And notice the type for the current states is simply an integer, which means maybe, for example, if we have 6 different states, the current state may be 1 or 2 or 3 up to 6, only 6 possibilities, right? That's the current design. Since there's no objects, it's not OO. And the idea would be we're going to start with some initial states, and then repeatedly we're going to make some transitions. Okay, let's see how the code structure looks like. You can see we have some from until loop over here. So we have the current state you can see from. That means we want to initialize the system. Current state is simply assigned to initial. You can think about initial is certainly maybe some constant or some input from the user, but it's integer. And then until we reach the final states, right? Maybe the final state is simply after the user has confirmed their payments, and so they can log out from the system, right? So it's finally just some query, okay? And then if it's not final yet, we're going to execute the body of the loop. So we can say execute state is actually, if you look at the diagram here, execute state is actually the middle level, but we'll go there in just a moment. So I'm still trying to explain to you what's the overall structure for the execute session. So far we talk about initializing the states, and also we're going to talk about execute state. And then also is final also is mentioned. Okay. The execute state, basically you can say, depending on what the current state is, which is an integer, it could be 1, can be 2, can be any of the 6 possibilities. And then we're going to do something specific to this particular states. Okay? And then finally, you can see this line here. We say current states is simply assigned to the return value of the transition. Transition is the function we just defined previously, right? Given the current states and given the choice, we're going to make the corresponding transition and then update the current states. Guys, any question about this overall structure over here? You can think about this is going to run indefinitely, basically, until the user has actually confirmed, has finalized their reservation for the system, right? So it may run for 10 minutes, it may run for 40 minutes, depends. Okay. The only thing I want you to keep in mind is the current states is actually integer. And then if you want to do something about the current states, it is this particular execute state, which I'm going to talk about. And in order to execute that particular state, you have to pass as arguments the current state number, which is an integer. Okay? Okay, so far we have finished about this particular execute session, right? That's done already. Okay? And then, as I said before, the most important information to look at will be current states, which is integer. Okay? And now we're going to look at execute states, which is going to be the next level. Okay? That's the first level. Well, somehow in the textbook it's a level 3. Okay, let's stay with the textbook. We start with the top level 3, and then now we're going to go down to level 2, and that's the execute state. Let's see exactly how execute state is going to look like. And don't forget one thing. We are passing the current state. So you can think about conceptually, from the execute session, for this particular action here, we have to pass the current states. That's something that's passed around, okay, as arguments. So now let's look at how the execute state should look like. Okay? The execute states should be very similar to the labeled states in the first solution. Remember, we show one of the labels to say, in order to really execute each state, you have to somehow ask the user, for some information, display the states, display the state information, and validates the input. Basically, that's what you will see. Let's look at the code very quickly. So now, let's say execute state, right? Okay, it's a different level already. So now, given the current state, which is integer, we're going to do the following, okay? Overall, it's going to look like this. Overall. For this particular execute states over here, okay, over here, that's what we're talking about. Execute state is going to split into several stages again. That's why it's called top-down or hierarchical. We're going to, first of all, display something and then read the input from the user, and also do some validation, and also output some messages, and also process the user's choice. Notice that every stage over here depends on what the current state is. You might do things differently depending on what the current state is. Yes, question?
The relationship between execute session and execute state, is it client or?
Oh, good question. It's not client or supplier. Think about execute state is like a function that's being called within execute session. Okay, I'll show it to you. What I meant was this. Let me remind you, it's a good question. It's good to clarify. So you can, first of all, you can think about execute session over here. It is a routine, right? Like a command. And then you can think about execute state is simply like a helper. routine of execute session. So it's not really client supplier or inheritance. It's just about calling that helper function. Okay, let me just say it again. Basically, somewhere in the execute session over here, you're going to call this particular helper function called called execute states. And then when you do the execute states, you're going to call 1, 2, 3, 4, 5. 5 different helper functions. One is called display, one is called read, correct, message, and process, like that.
So would they all be in the same class?
Well, remember I said this solution here is not OO. You can think about it's more like a module, like different files. Yeah, I would say how you split it into different files, like in C, is kind of up to you. Yeah, but there's no class here. Okay, guys, let me emphasize again. The second solution over here is not OO, so there's no notion of class. Although when I show the syntax, I kind of show you the iPhone syntax. Just don't get confused. Okay. It's a good question, actually. It's good to clarify. So whatever we're doing here, we're just making that helper function call. Okay, let me go back to this guy here. Okay, execute state. How should it look like? Okay, given the current states, we're going to do the following. Okay, I just declare some local variables. You know, just whether the answer, what the answer is from the user, and also whether the answer is valid, and also what's the choice. Maybe the user wants to go to state number 3, or will go to state number 4. Depends. Okay, again, it's going to be a loop over here. We're going to say until we get a valid answer from the user, okay, for this particular state. We're going to do the following, okay? First of all, we display information according to the current states. You can see that over here, it is necessary to pass this current state further to this helper function called display. Because without knowing what the current state is, how can you display? Maybe one state should display, thank you for confirming your reservation. Another state should be, please welcome to the reservation stage of your, of your process, right? So it depends. After display, now we're going to say, depending on what the current state is, we're going to read the answer from the user. Maybe in one state, you're going to read in departure and return dates. In another state, you may want to read in their credit card number. So again, it depends. Okay. After that, you're going to say, okay, so now let's say we are done. So where would you like to do next? The user might say, I want to go to state number 4. In that case, it may be valid, may not be valid, depending on what the current state is, right? And then we're going to validate their answer, right? Whether the credit card is actually valid or whether their return date, departure date is valid, right? Depends. Okay, so now we simply say if the answer is not valid, and then we're going to give them some error message or a confirmation message, right? Again, depending on the current state. Okay, I keep saying depending on what the current state is, the display, re-answer, re-choice, and correct and message, they all look different. Depends. Okay? Any questions so far? Just about the code structure. Any questions? Let me just emphasize once more. Okay? So far, we have already gone through, basically, starting from this top level function. Inside this particular function here, we try to initialize, we try to do transition, and specifically this particular helper function, I showed that in detail, right? For this particular helper function here, I try to do display, I try to do read, I try to do correct validation, try to do message, try to do process. More specifically, when I go from execute session to make this particular helper function call, I have to pass the current states. Similarly, when I try to execute the states and when I try to call each one of them, I also have to pass the current states. Okay? Current states, current states, current states, current states, and current states. Logically, that makes sense because if I want to know what to display, I have to know what the current state is, right? Questions? You okay?
Yeah, but so your session never changes. Like you can never go from, I guess, 1 to 2. That only happens now.
Oh, okay. That's correct. That's correct. So the only thing you change is when you do the current states. So basically, you can think about after you execute this particular execute states, you're going to update the current states. And then remember, this part over here is iterative, which means you're going to keep executing this particular process over and over. So as this current state changes, the way you execute this is the same, but the output will be different because the display, read, correct message will be different, right? Yes. Okay. So this will be done iteratively. Okay, just to mention. Okay. So guys, let me just see. I mentioned everything. Okay. So now the only thing I want you to pay attention to now that we have seen this, current state is over here, and now it is passed to display, re-answer, re-choice, correct, message, and process. Okay, that's what we have seen so far. And I believe I have a question for you on the slide. Let's see what the question is. Okay, that's basically what we have, right? In case you have doubts about what each one should do, you can look at that on the slides. Now, question. And that could be a reason for criticizing the design. You got questions?
Before you ask us the question, you said, before you answered John's question, you said logically that design makes sense. Were you going to complete that by saying something else in terms of logically, yes, but then in terms of actual implementation, that has
No, I'm just saying somehow this design makes sense because you don't have classes. It's not OO. So the way it works is by just defining different functions. You can call functions within a function. You can help a function. So that's why I said it makes sense. Because you have no classes or objects. There's no such concept.
what is it wrong? What is it that why?
Why is that bad design? That's something we're going to talk about. Okay? So guys, consider this question here. How similar are the code structures of all the helper functions here? Display, re-answer. You can see display is going to do something very different from re-answer, right? Also, re-answer is going to be very different from process. Process is also going to be very different from message. I mean the purpose-wise. But are their code structure look very similar or not? I heard yes, good. Get a good sign. You might want to say something. That's true. Each state has to check what the current state is. So you would say if current state equals 1, do something. Else if current state equals 2, do something. Agree? That's what you meant, right? Okay. Why is that bad? What we just agreed now is to say every feature, every sub-function over here, you're going to say if the current state equals 1, do something. Else if current state equals 2, do something. Since we've got 6 different states, it seems like we're going to somehow repeat the same control structure, if statement structure, for 6 times, right? Depending on how many features you have, okay? Why is that bad? What principle would it violate? Single choice principle, good, exactly. That's a good sign. Okay, you guys are improving, that's good. So now, can you tell me how exactly it is going to violate single choice principle? So in case this was asked in the exam, the way you explain design principle is violated is by giving a scenario, okay? What kind of scenario can you say about violating single choice principle? And typically, the scenario should be you're making some change to your system. What kind of change can you make to the system? Chelsea, yeah. Sure. So what Chelsea just said was, what if we try to add another state? Okay, let's see. Let's first of all see the code structure, and then we can be more precise about how to implement your change. Okay, I'll just show one of them. Okay, so basically you can see over here, I will simply just show you. So we talk about just display. Okay, and the read, correct, message, process, everything else will be similar. Okay, I'll just show you one of them. Basically, what you got to say is have some precondition to make sure the current state is valid, and also if the current state is 1, do something to display, and if that's 2, do something else. Okay, etc. Since we got 6 different states, so there should be 6 different conditions to check. Okay. So now, Chelsea, tell me, if you want to introduce a new state, let's say state number 7, how many changes do I need to make? Aha, exactly. Basically, what's going to happen is, let me go back to iPad and illustrate to you. Let's say for this particular one, we talk about display over here, right? For that particular guy, I may have to say else if, let's say the current states equals 7. In that case, I got to do something else over here to define what the new state should be handled. Not only displays over here, not just display, I got to introduce state number 7 to read, to correct, to message, and to process. I got multiple places to change. So apparently a violation of single choice principle. Guys, is that clear? Okay. I wonder if this can cause any recollection from a previous lecture. Okay, I kind of predicted I'm going to talk about that example again. Okay, I'll show you what I meant. Okay, I think it's worth doing a little bit cross-reference. Okay, if you can just bear with me just for just 20 seconds, I'll find it out. And it's really worth making this reference. When I talk about inheritance, basically, do you remember this diagram by any chance? I know it's very messy, I know, but when we actually ask you about how can you really try to distinguish between resident students and non-resident students, one option would be the guy who suggests, oh, actually you were the one who asked me the question, I remember, yes. So now, in this case, if the kind over there for the students can be either 1 or 2, and then for every, let's say, tuition over there, and also for charge over there, right? For whatever feature you want to define, you have to distinguish between different kinds of students. They got to say, if the kind equals 1, do something. Else if kind equals 2, do something. And as said, that one is very bad because it violates single choice principle. Now, can you see this is the same problem over here? Basically, the fundamental difference between non-OO and OO is the way you distinguish between the kinds of objects is different. In the case of non-OO solution, the best you can do is to have some attribute or variable there to encode the kind of objects. It can be like a different states or different students. Okay? And we say it violates single choice principle. Okay? So I would suggest when you study that the state design pattern, especially when you get to the non-OO solution, remember this diagram here. Okay? It really links together. It connects. Okay? Let me go back to where we are. Okay, I'll just go back to where we are. I believe we are over here. Okay, so now how can we improve? So now we're going to move from non-OO to OO solution. Okay, let me tell you straight. I'll go straight to the point. The point is, let's compare the two different kinds of solution over here. Okay, let me go a little bit slides with you, and then I'll come to this slide here. Okay, such design smells because you got lots of duplicates, right? So that's not good. Single choice principle. Okay, so also this is something I just illustrated. You basically pass the integer current state around, which is not good. And there is something called law of inversion. Okay, I'll read it out to you and I'll try to explain what the intuition is. If your routines, for example, display, message, correct, etc., exchange too many data, which means you always pass the current state integer around, then put your routines in your data. That part sounds a little bit strange. What does it really mean to put routines in your data? Because the state, the data has been exchanged so often, why don't you make the state as a class itself, now that we got OO? That's basically what we're going to see. Okay? But you don't have to worry about the definition here. It's a bit not so intuitive. All right, let's see that. Okay, that's something we talked about before. Okay, we're going to move from this particular non-OO solution to the OO solution. There are two things we have to do. Number one, we have to modularize the notion of class states, which means we can create a class called states. Number one. Okay, that one is easy. Number two, we're going to somehow encapsulate, which means we're hiding or you're putting. You're putting all the state-related information into the state interface or class. So what would be the state-related stuff you got to put? Display, message, correct? Basically, think about this. In the non-OO solution, we had things like display, read, correct, message, and process. In the OO solution, the state itself is going to become a class. And all these particular functions will become like a commands or queries in that particular state class. So it's a single place we hold this kind of information. Okay, that's basically what's going to happen. And now I want to show you the insight into the difference between these two solutions, okay? And then we'll see how exactly you can implement the OO solution. So now, first of all, let's have a look at the top-down, I mean the non-OO solution that we just went over. Okay? The way we declare the current states is simply just using integer. Right? Whenever we want to execute the session, we have to execute the session, we got to say current states. Actually, I made some typo here, beg your pardon. What I meant to say over here is execute the states. Okay, execute the states. So in the non-OO solution, the way to do it is by saying execute the state. It's like a function call, and then you pass the current states as the arguments. That's a non-OO solution. So we're passing around the current state integer. Now, before we show you how to implement the OO solution, what's going to be the outcome? What if you are the clients of the state pattern? You can see the fundamental change over here. The change will be, now when the clients want to declare, they would say the current states is now, rather than integer, is going to be a reference type called states. How do we execute states? Well, all you got to say is the current states dot execute states, or execute. Can you see the difference here? You can see there's no argument passed to the execute states in the OO solution. Why is that?
Because the current state class will have the current state as an attribute.
Not quite, not quite. That's exactly right. That's exactly right. So now, remember when we review the inheritance, the most important two concepts, one is polymorphism, the other is dynamic binding. In this case, okay, both will actually be very useful. When we say the current state was declared to be of type states, dynamically, what can be the binding for that particular current state? It can be any of the subclasses or descending classes of state, right? That's polymorphism. Dynamic binding tells us when you try to say current state.execute, even though there's no arguments, which version of the execute state is going to be called depends on the dynamic type of current states, which can be any of the 6 subclasses, right? Guys, it's only a very quick overview of the difference between the two approaches. I would say this slide is the most important one for this lecture here, right? Now the rest will be just about the specifics of the state pattern. Any question here?
So you're not showing the and finding on the state feature.
Yeah, because here the state itself, the state class here, will just be a deferred. And then it's going to have several descending classes that's effective. And then depending on what the dynamic type is for the current state at the runtime, you're going to execute the corresponding version of current execute state, basically. Jordan.
So the display read correct messages process will be subclasses of execute state? Is that what you're saying? Or
Nope, that's not what I meant. Okay. Yeah, I haven't really shown you anything yet, so that's my bad. But anyway, so what Jordan was asking was, when we talk about display, read, correct, message, and process, should they be like different classes? The answer is no, that's not the case. What's going to happen is like this. Now, let me be very precise to you. Okay, this is not in your slides. I can write it out. So we talk about 2 different solutions. First, we talk about non-OO solution. Okay, and then where we simply got current states. And then it's simply just integer. Okay? And let's say we got different states. It can be from 1 to 6 conceptually. Okay? And then let's say from state number 1 to state number 6. Okay? And then we have something called execute states. Okay? In which case we're going to pass the current states and then of type integer. Okay? And then we also got sub-functions over here. We got display. That's also going to take current state of type integer. And also, let me just put another one. And message, also current state of type integer. Okay, so these are all the functions that we defined in the non-OO solution. Okay, now back to your question. How do they translate to the OO solution? Here's how it's going to happen. First of all, in the OO solution over here, we're going to introduce a top class that's deferred called states. Okay? How many subclasses we should have depends on how many states we have over here. since we got, let's say, state number 1 to state number 6. Let me just put it symbolically, okay? So 6 different states, you're going to have state number 1, state number 2, all the way to state number 6. So you can see what not really the display or message, not any one of them will be turned into class. But where should they go? Okay? The answer is somehow display, how it works depends on the dynamic binding of the current objects. So they should appear as deferred on the state class. So what's going to happen is, let's say display and message. So display over here, deferred, and also message over here, also as deferred. And they will be implemented over here. For example, display, that'll be plus, and also message over here will also be plus. They will just be plus for every concrete classes over here. What's really interesting is what happened to this particular one. Execute states. Okay, we're going to see that. Okay, we're going to see exactly how we're going to put it. We're going to put it exactly over here. Execute states. However, itself is going to be effective, not deferred. Okay, I'll go into detail with you. But when you see that, you will see that in the state class, basically every feature we put there is deferred, except for execute states. Because the pattern for each state, like you have to do display followed by message followed by whatever, the pattern is really the same. So you don't have to repeat them. So that's why it's already effective. Question?
Does this have something like, can you relate this somewhat to open-close principle? Because what if, for example, we don't have a change of states, but we could have a change of commands, like instead of display message, we could add another one. Would it be the case that we should stick with the old one?
Oh, interesting. You talk about open-close principle. You know what? Let me think about this. Maybe I can mention that in the beginning of the next lecture. Okay. The question was, how is open-close principle going to affect us over here? Basically, should the number of states be open or closed? And also, should the various operation we can do on the state, should it be open or closed? Okay, I'll prepare something. We can talk about it. Yes. Guys, think about it. Okay. We can talk about it next time. All right, that's kind of the roadmap for what's going to happen. Okay, let's see the details. Okay, so that's going to be basically everything is we're going to have a new state, new class called states. That's the architecture. Let's have a look. Okay, again, before we see the code, let's see the architecture. Okay, just for your information over here. Okay, so now we got this state, finite state machine. Okay, and this is the bound diagram for the state pattern. Let's have a look. First of all, the clients of your application, that's an application, right? And then it's going to have a client supplier called states somehow, right? They refer to the states. And then the state class, as I said before, is simply just deferred. You can see that over here we got read, display, correct, process, and message. They're all deferred. In each of the descendant classes, you can see somehow I just say the cluster is the whole thing inherits from state, which means every class in the cluster is a subclass. Okay, just a convenient notation. And then, for example, you can see initial over here, since it has a plus, that means every feature that's inherited to initial, including read, display, correct, process, and message, they're all implemented. That's implicit. Okay, so you don't have to say read plus. You don't have to, because the fact that it is effective tells you every deferred feature has been implemented. Okay, and as I mentioned before, execute. Oh, so execute here simply means execute states. Okay, simply means that. Okay, execute here is the only feature that is effective. That's the only one, which means at this level for the states, we know already how the execute pattern should be. However, in the pattern of the execute, we might have to refer to read, display, correct, process, and message that are deferred. That's the kind of interesting part. Okay, we'll see. And you can see a little bit stuff over here. Okay, let's have some check quickly. Okay, let's say we are trying to, I'm trying to use this pattern over here. Let's say I declare S to be of type states. Okay, you can think about S is just a reference variable. Statically, it's states. According to the rule of polymorphism, I can assign any dynamic type that's a descendant of states, right? So I got 1, 2, 3, 4, 5, 6, 7. 7 different options according to the architecture. Okay. So now, if I say creates s.make and now dynamically want it to be sit inquiry, what it will do is it's going to say after this particular one, s is now going to point to a sit inquiry. Sit inquiry over here. So now a question for you. If I call s.execute at this point, which version of execute am I calling? You said sit inquiry. Okay, are you sure? Did I actually do anything in the sit inquiry for the execute? In the state, actually, right? You can see over here, in all the descendant classes over here, notice that, okay, I will write it out. Execute, which is already effective in the parent class, right? It's not redefined. If it was redefined, I would have shown, but it's not. Okay. So now, the s.execute over here, even though, well, dynamic type, I know that it's got sit inquiry. So it's going to call version from the states. The same, just the same execute feature from the state class. Okay, let's do another one. And then I'm going to say here, let's say I try to change the binding of S. What this will do is it's going to say, now I change the confirmation. That means S, rather than pointing to here, it's now going to point to confirmation. So now, the same question. When I try to do s.execute, which version am I calling? The same class state, right? Okay, it's also from over here, the same. So there's only a single version of execute that's already defined the state class. We don't change it. And there's a name for this particular. When we talk about state pattern, we actually show you two design patterns. So this one is called template pattern. You will see that in the slides. Okay, it's called template. Meaning that we define this particular execute as a template for every subclasses. The only thing that's going to be different between classes would be like a read, display, correct, process, and message. Okay, we're going to see details. All right. Any question about architecture over here? Any questions? So you can see that the state pattern over here also relies a lot on polymorphism and dynamic binding, just like a visitor and composite, right? But you can see each design pattern is trying to use the same principle, but in a slightly different way. So that's why it's so important for you to grasp the idea. Any questions? The only thing I didn't say yet, the only thing I haven't covered yet was when I say I'm trying to call the same version of the execute, but how exactly is the body of the execute going to be executed over here? That's the question. Okay, we're going to see that. Okay, once I show you the code. Yes. Should all the, you mean the, what different, you mean the read, display, correct, process, and message? That's, yeah, that's worth thinking. Yes, I would say the micro concern was, over here, when I show execute, read, display, correct, process, and message, I kind of imply that they are all public. If you believed the user should never call the state.read or state.display separately, in that case, of course, you may want to make them private. Absolutely. But for illustration purpose, I want to show them to you. Right? Good. Good concern. Okay, I would say let's read a little bit of code over here. So now I'm going to show you the code for states and also for individual ones. Okay. Okay, the state class is the most important one. Let's see some detail, and then I'll switch to iPad. Okay, first of all, the state class is deferred. All right, and then the read is deferred. Not surprising. The answer, well, just some value like attributes. The choice is also some attribute here. Display is deferred, and also correct is deferred. It's like validation, and also process is deferred. Message is deferred. So far, I'm talking about all these being deferred. What's being left? Execute. Let's see execute here. According to the architecture diagram, execute with a plus. That means you should have some code for execute, but let's see exactly. That's an interesting bit. Okay, so here I'm saying every subclass, every descending state class is going to inherit this particular execute and without redefining it. Okay, so for every state, you're going to say execute and then with some good local, okay, and then until the user has been good on their answers, right? Until everything has been validated. We're going to first of all do display first, followed by read, followed by validation, and then followed by if the validation has failed, we're going to give them some error message. Does this feature make sense to you? What's really interesting about this particular command over here is the command itself is effective because it has code. It's not deferred. However, the way we implement it is by referring to all the deferred features on the left. That's valid. I'm not sure if you ever did this in Java. If not, that's okay. We're going to learn something new. It's absolutely allowed. You will see how beautiful it's going to work out later. Okay, I'm going to do another illustration to you once you have seen the code. Oh, of course, we also got process, which is also deferred. Guys, any question about the code itself? Any question? Any concern? Any? Sorry? Oh, what do you mean? No, that's not what I meant. I asked if you ever did this kind of pattern where in a Java method you call something that's abstract. I'll ask if you ever did this before. If you haven't, you're learning something new today. So this idea is not IFO specific. You can definitely apply that to whatever OO language you're using. Okay, that's my point. Okay, okay, let's have a look. It's really worth getting that straight. All right, let me go back here. Okay, I'm going to illustrate again. Okay, once more. Let me now just say it again over here. Let's say this guy here, this, I'm going to use, let's say, blue to say this particular feature command is effective, is implemented. On the other hand, all the others, I'm going to use pink to tell that they are deferred. Display is deferred, and also correct, process, and message, they're all deferred. And notice that we are referring to them inside the body of execute. Right? We are using deferred features, which are pink, inside a particular effective feature, which is blue. That's basically what I'm trying to illustrate. So now we're going to see the same two lines of code are going to be executed. Okay? Now we can make the picture complete. Okay? Let's see this. Let me remind you one thing very quickly before I talk about it. Okay? So remember the hierarchy over here. I'm going to redraw it just partially. Okay? Remember we have states over here, and then we have execute. Of course, execute itself is actually effective. And also we have, let's say, only two of them. Let's say display. Oh, let's say a display. Display is, oh, let me be consistent with the color I chose, pink. Let's say over here display, which is deferred at this level. And also I got, let's say, message. That's also deferred. Okay, just show two of them. Okay, the rest is similar. And then under this particular class, let's say I only show two subclasses. That's in the context, seed inquiry and confirmation. Okay. One subclass is called seed inquiry. And the other one is confirmation. That's effective, of course. Confirmation. Okay, even though it's not necessary, but I'm going to emphasize the point. Okay, at these two classes, the display and also message are both effective. They're both. And also display over here, and also message over here, they're all effective. Okay, that'll be enough for us to see the polymorphism, dynamic binding, etc. All right, let's see this. Let's trace the code again. Number one, you can see that over here, we're trying to declare S to be of type states. So S is just a variable over here, right? So now in this particular line over here, where we say creates seed inquiry over here, dynamically S is now going to point to a seed inquiry objects. Okay? So now I'm going to highlight what I expect from you to explain to me. S.execute. Question number 1. As we said before, we're going to execute the same version of the execute in the state class. Agree? That's what we said in the previous one, right? That one I don't need to bother you. Let me write it down first. First of all, we can say over here, dynamic type is seed inquiry. Okay? And then execute from the state is called. Okay, that's something we knew from the previous illustration. Now, here's my new question for you. What's going to happen when I try to execute the, what's going to happen when I do this particular line? It's going to execute the body of this particular command, agree? And then the first thing it's going to encounter will be, for example, display. But now, display is actually deferred. How is that going to work out? You see my point? I'll pause a little bit for you to think about. Let me make my question clear again, okay? After this particular line, after this line here, I know that S is pointing to some seed inquiry objects. And then I try to call S.execute. And we know that the execute, that's the version that's going to be called. There's only a single version, so we have no choice. We're going to call this particular execute over here. That's the only one. It's not really defined anywhere. So we are basically calling this particular execute command. And then when we try to execute line by line, for example, the first pink we're going to encounter is display. And according to the definition here, display over here is deferred. How is it going to work out? I'm going to run into some runtime issue, or it's going to work out perfectly? Okay, so basically what's going to happen is, according to the architecture, we know that display, for example, is guaranteed to be implemented in all the descendant classes, right? Let's call that this is version 1, this is version 2, right? And now, dynamically, S is pointing to some seed inquiry class. So that means we can call either version 1 or version 2. Which one? Version 1, right? So that means when you call display over here, dynamically, it's going to see what the dynamic type is. In this case, dynamic type is seed inquiry, so it's going to call version 1. Okay? I'm going to write it down. And also, okay, I'll continue from here. And also execute the display from seed inquiry. So this is something I didn't mention in the previous one. But now that I show you the whole picture for the states, now you can see it. Again, why is this called a template pattern? It is simply because you define the same overall control structure. Like you have a from, until, also display, followed by read, followed by correct, followed by message, followed by process. It's more like a template. However, how exactly each step should be done depends on where you are in the descendant classes. So that's why they should be implemented over there. But at the abstract level, you don't have to define them. So that's the beauty about this particular pattern over here. Okay, similarly, before I take your questions, similarly, if I try to go on, okay, let me complete the picture. Now, if I try to execute this line over here, so that means I'm changing the dynamic type for S. So now S, rather than pointing to here, it's now going to point to a confirmation objects, okay, confirmation. Okay, so now at this point, and then we're going to see exactly the same line. Okay, S.execute. At the moment here, the dynamic type of S has been changed to confirmation. Agree? Okay, let's write it down. Okay, so now over here, dynamic type has been changed to confirmation. And now, which version of the execute will be called? From which class? Stay, right? There's only a single version, no brainer, right? Okay, so execute. Okay, I'm going to continue into here, right? Sorry, just running out of space. Execute from the states is call. And when we try to execute this particular code fragment for the second time, and when we encounter display, is it going to execute version 1 again? Yes? No? No, because dynamic type has been changed. According to dynamic binding, which version you call depends on the dynamic type, right? So now, would you agree, when we try to execute this line over here, and when we hit this part over here for display, right? Display over here, it's going to say, because dynamic type is actually confirmation, so we're going to execute a version from confirmation, right? Okay. So you're going to execute display from confirmation, okay, versus C inquiry. So dynamic binding is really in effect over here to make it work. Questions?
Whenever I choose dynamic type, everything is going to follow.
Exactly. So you're exactly the right observation. Every time, if you want the state to behave differently, all you gotta do is to change the type, the dynamic type of the states. Everything will just work out, assuming that you have correctly implemented the display, for example, in every class. Assuming that. Okay, right? Questions? What if the client has, okay, it's not going to happen because you're basically suggesting the following. Correct me if I'm wrong, okay? Let's say S is of type states. When you say static type and dynamic type are the same, you're basically saying creates, let me write it down. Is that what kind of what you meant? Okay, good. Guys, would this work? How would this work? It would not. Would it even compile? Aha, exactly. Well, basically, it's like in Java, if you have a class that's abstract, you cannot use abstract name as a type after new keyword, right? The same idea over here, right? So now back to your question. Because we deliberately made the state class deferred, so you can never put state as a dynamic type. So don't try that. You can try and then confirm. That's actually not allowed. Okay? Yeah, because when you say deferred, it's more like an abstract in Java. Deferred simply means for the current class, I got at least one command or query that's unimplemented. That's what it means. They don't, well, no, they don't. They don't have anything called interface. So they can, if you really want to make an interface, like in Java, you will just make everything deferred. Yeah. Mm-hmm. Yeah, because I kind of mentioned maybe very briefly back in 2030, I mentioned you can think about interface is like extreme case for abstract class, right? Where everything is abstract. Yeah. Okay, so just want to mention, okay, so this is not going to compile. Okay, it's not going to compile because this is deferred. Okay. Guys, before I leave this page, any question for me? So you can see so far all the patterns that we talk about, right? Maybe iterated not so much, but I would say the composite, the visitor, and state pattern, and then we're going to talk about another one maybe about 2 weeks from now, observer. All of them make use of polymorphism and dynamic binding, right? So that's why I said the concept is so important. Okay. Anything that's not clear? You want me to explain more to clarify? I mean the green, I mean the hierarchy over there. So you're talking about the state class, which part? Which part of the state? Okay, so we have, so that's a pattern, that's a hierarchy for the state pattern, right? So you define the states as deferred, okay? And then under which, depending on how many states you have this many state descendants. Because according to the diagram, remember we got 1, 2, 3, 4, 5, and 6, for example, right? If you got 6 different possible states at the conceptual level, and then you should have 1, 2, 3, 4, 5, 6, 6 different descending classes. Right? That's a pattern. So I only showed 2 over here. I didn't show the complete ones. I only showed 2. That's for illustration. Right? Guys, any other questions? We okay? All right. Let's see a little bit more. So we're going to see how exactly you can implement the rest, right? Just in case you find that useful for your projects. May be useful, may not be useful, right? Okay, so over here, we already talked about it. Okay, so this slide here, basically exactly what I have illustrated. So you will simply use a template design pattern, and then think about how dynamic binding works. Okay, make sure you know how to explain it. Okay. Okay, so now, guys, hello. All right. This is basically the runtime for the state pattern. Remember we talked about polymorphic collection, polymorphic array. So this is just another example for this. Okay. Basically, we're going to see exactly how to build this array. We'll see that. Don't worry. We're going to see that. Okay. But it might be nice to show this a little bit quickly. Okay. Basically, for the state pattern, when you do it at the runtime, first of all, that's the application. Okay. When people want to use your state pattern, let's say application, there are 2 things that's important. Okay. Number 1. They should have a transition table, which is simply an array 2 of integer. So the transition table itself does not store any state object. It does not. Okay? And then you simply got transition table. That's exactly what we showed you previously, right? For example, you can simply say if you are in state number 1, and then you choose option 1, you go to state number 6, okay, and etc. That's a transition table. And what's interesting is about the states over here, which is an array of states. That one there is polymorphic. Okay? The size of the states, the size of this array depends on how many possible descendant classes you have for this particular application. Because we got 1, 2, 3, 4, 5, 6, we have 6 different states. That's why the size is 6. Rather than saying at a runtime, if you keep switching between states, you don't keep growing the array. The array size stays fixed. It never grows, only 6. So what you're going to see is the current states, being a states, is going to be reassigned to either the first position of the array, or the second position of the array, or the third position of the array. That's what you're going to see. Okay? So we switch the dynamic type of the current states. That's what you will see. Okay? Any question about this diagram here? Yeah, Jordan. Yes. Let's say, yes? Exactly. That's good. So what Jordan's concern was, according to the 2-dimensional table, let's say this. You are basically referring to this particular cell. Okay? Let's say this cell over here. Okay? Where the hand is. Let's say I am in state number 2, and then I make choice number 1. So now, true, according to this, it's going to return like a void or 0, for example, right? However, your code should never let this happen. It should be part of the precondition for the transition to say if you're trying to give an option that's not supported for this particular state, you should really give some error, or simply just basically give some error. So you should never reach this. Yeah. Okay. Or return something that's sensible. Yeah. Good. Question.
If you were to switch state, whereby if you were to go from 1 to let's say 2, would that mean that you're working in the same array, or would you create a new
the same array? Okay. Yeah. Let me tell you what's going to happen. I'll give you the precise idea. Let me just copy this. I'll switch to iPad in just one moment. Bear with me. Okay. Oops, that's a bit too much. So what I want to do is I want to show you an idea about how things work. Okay, and then can I also copy this diagram here so everything will be ready? Okay, that's what we have. That's enough. Let's talk about a single state transition. How is it going to work? Let's talk about a single one. Okay. Let's say this is conceptually what I want to happen. Let's say currently I am in flight inquiry. Currently. And then I would choose option number 3, which will lead me to state number 3 for seed inquiry. Okay, let's say that's something I want to illustrate to you. Okay, let's see exactly how this is going to happen. In the actual code, you will see some loop to generalize this pattern. I'll just show you one occasion, okay, one scenario. Okay, we'll start with this. Let's say over here, current states of type states. You have to use the top level state, so you can have polymorphic assignment, first of all, okay? So now let's say if we want to start with this particular state, let's say, so what you would say is, just allow me to write CS for current state, right? So I would say creates, okay, I would say flight inquiry, okay, flight inquiry over here, current states dot make. Oh, actually, I beg your pardon. I don't need to do this anymore. Sorry about that. What I meant to say was this. First of all, you can see a flight inquiry has state number 2, right? So that means you should really go to index number 2 of the array, which has a flight inquiry objects. Okay, so what do? I don't need to create any new objects. Sorry, that was my mistake. Okay, so now all I need to do is like this. Current states is assigned to states array, right? It's polymorphic. I can say states at position 2. I'll pause a little bit here. When you see the application code, you don't keep creating state objects. You don't do that. You only create 6 different state objects with different dynamic type. That's all you do. That's the main point. Okay? And then every time when you want to switch the states, you don't create new state objects. All you do is find out the index in this particular array, which is fixed size, and go for the particular position and assign it. Okay, so now, how do I make this particular transition over here? Let's talk about it. How do I make this? So what I would say is, again, we got transitions over here, right? So I would say, let's say over here, let's say next states is integer. Okay, just integer, some return value basically. So I can say the next states will just be calling the transition function. And I want to say I'm now in state number 2. I choose option number 3. So now I'm in state number 2. I choose option number 3. I should get 3. Agree? Okay, so now I know that the return value over here should be 3. So far so good? And now, how do I update the current states? It's assigned to the corresponding index, right? Basically, the transition function itself only manipulates at the integer level. This is to avoid that you keep creating state objects. You don't want to do that. It's too wasteful of the space. Okay? So after this, what you will do is you will say, okay, now I want to go to this particular state. All I say is current states is assigned to the states and next states, which is integer. That's how the state transition is going to happen at the runtime. Or, more precisely, you can think about the current states is like a variable, right? After this particular line, current state is now pointing to this particular objects. And after the state transition that we implemented, after this line, so now it's now going to point to seed inquiry. Okay, that's what's happening here. Question? The transitions array, it should be, yeah, that's why you see array 2 over there. Yeah, good. Just in case you miss it. Of course, you need the 2-dimensionality to handle this. So that's why you see array 2 over here. Yeah. Guys, any question here? Yes. The 4th line, yes. 1, 2, 3, 4. Okay, sure. You need a red one here. Okay, this line over here, we are basically trying to make a transition. Let's say we are in state number 2, and we choose option number 3 as a transition. What should be the resulting states? We should ask the transition table. According to the transition table, basically the rows are simply the states, and the columns are the choices, right? So now, if you're currently in state number 2, right? So that means we're considering this row. And then you're saying that you want to choose number 3. So that means number 3 is here, so intersection is here. So that should be the return value. That tells you you should really now go to index 3 objects that's stored in the array. So state number 3 is referring to the C inquiry. So that's why you want to switch there. Right. Questions?
So because choice is going to be deferred, but it's going to be
Oh, no. Choice, I see. Okay, let me just double check. I kind of see where the confusion might come from. Let me just make sure. Okay, no, actually, that's fine. So you can see maybe you were confused with all the features over here. You can see there's nothing called choice. Okay, so choice over here, thinking this way. The choice over here is simply the transition. And it's simply just integer. It can be 1, can be 2, can be 3, etc. Yeah, just don't get confused there. Guys, any questions? Okay. All right, let's continue. Okay, if you really got this part here, I think you basically got 99% of the state pattern, which is a little bit more code to show you, but that's the main insight. Okay, when you see the later code, it's exactly this kind of illustration, so I don't need to repeat. Okay, so what you will see, let's see some code over here. So let's see the application class. So this is the clients of the state pattern. Okay, so application over here, and then if you want to, every time you want to really use the state pattern, number one, you have to, from your point of view, first of all, for your design, start with a conceptual finite state machine like this. Start with that. Make sure you're comfortable with it. And then you're going to translate it into this particular 2D array, the transition table. That's what you would do. Okay? So over here, that's array 2 over here, right? And then also you got the states, which is polymorphic. Okay? And also you have some, what should be the initial state? You can see is integer, right? The index, basically. Okay? And also number of states depends on your application. It can be 10, can be 100, can be 1,000, depends. Also number of choices, like a number of transitions you have, right? Okay, so you can just initialize them. So that part you can just read the code. I don't need to bother you. Okay, question for you. What should be the invariants over here? Any invariants you can think of? I'll give you a little bit hints. What should be the relationship of the dimension size of the states array and the number of states and number of choices? Well, when you say size of the 2D array, right? It's 2D, right? You can elaborate on that. Yeah. Oh, actually, yeah, sure. The states array, yeah, I agree. So the size of the states array, so you can say states that count should be equal to the number of states. For that one, I agree with you, absolutely. What about the 2D array over here? Transition. How about this? The number of rows for the transition should be equal to number of states, and the number of columns should be number of transition, right? Okay, good. That's exactly what you're gonna write. Okay. You can see invariant can be useful just in case you got things wrong. Okay, exactly like that. Okay. I should have put also states that count equals number of states. I should have put that. All right, let's see a little bit more. So how can you start the states array? Basically, you will just have to tell me the index and then put in the objects, right? Okay, you simply put it into the array. Okay, that part is also easy. Okay, basically the put states is going to eventually set up this particular array that's polymorphic. You just insert a state one by one. That's what you would do. And then also you can choose initial, which means what should be initial states. If the initial state should be the state object at index 2, you should say choose initial 2. Okay, depends. And also how you can put a transition. Okay, so now you simply say if you want to put a transition, just a convention. How can I'll just give you one example here. How can I set up this particular transition table? For example, how do I put in this particular guy? This guy over here is saying I'm in state number 5, and then I'm taking option number 2, and then I will be in state number 4, right? That's what this one is saying. How do I call that, right? The convention you will see for the put transition, we talk about the destination state first, and then the source state, and then the choice. So this one here, you're going to say put transition. Okay, target first, 4, and then the source, 5, and then the choice over here. The order doesn't really matter. I would say as long as you define that according to your satisfaction, stick to it. Okay, so just for this particular example, that's how it's set up. Okay, we okay? All right. That's about put transition. Okay, just some precondition you can look at, right? Just make sure the state is valid and the choice is valid, right? Okay, you can put it. Okay, and now this particular test, let me go over very quickly with you on the iPad. Okay, it's basically something you have seen already. Okay, so basically very familiar with it. Okay, let me see this. So all you got to do, number one, okay, let me make it bigger, like that. Okay, so you have to first of all create your application over here, and then you're going to say the number of states. Over here, the number of transitions. What this will do is going to initialize the 2D array accordingly, right? The dimension is going to be 6 by 3. Okay, and then you're going to initialize all the states, right? You can see what this does. Think about this. When I say app.put states, the initial state at index 1, what I'm doing is I'm basically saying for this particular application, for the states array, I'm going to now assign position 1, index 1, into this particular initial state objects. That's what I'm doing, right? And of course, for all the 5 remaining states, you can do something similar, right? You can say, I want to put into position 2 some states called flight inquiry. I want to put into state index 3, sea inquiry, right? Just keep doing that, right? And then I can choose the initial states. In that case, let's say 1, which is initial, will be the initial states, let's say. And then you can put in the transition, okay? Let's say I want, if I'm in state number 1, I choose option 1, I'm going to end up with state number 6. So this is exactly how I explain over here. Okay, you can refer to it if you got doubts. Okay, okay, almost done. And then this index is really, really important. This index is basically, if you refer to the previous one, this index here is basically the next states that I talk about the integer. Okay, we want to know where the index should be to reassign the objects. Index, and then the way you update the index is by calling the transition function, right? And then also, whenever you try to make a state transition, what you will do is, let me highlight it. You can say current states is assigned to the states at a particular index, right? That's what we did before. Also, if you want to update it, let's say index has been updated. You will say current state is reassigned to the new value of the index, right? You just do array indexing. All right, questions? You okay? I think there's a final fragment of code to see, a final one. Okay, so what about, for your flight reservation system or for your, like Amazon-like, online shopping system? Eventually, you want to really make the system interactive, which means you're going to keep interacting with the users before you can terminate, right? This is how the final code is going to look like. Okay, again, we have the same application class. Okay, we got transition, we got states, right? And remember, states is polymorphic. Okay, so this is the execute session. Okay, that's similar to as before, but now you can see the current state now is states, right? Rather than integer, if you compare the non-OO solution. Also, we got index. You can think about this as index, indexing into the polymorphic states array, right? States array. Okay, index is going to keep changing. And the way you change the index is by saying index is assigned to making a transition call, right? Calling transition. So now, all I expect you to explain, you don't have to do it now, well, think about it. Now, you got to think about why this line here illustrates polymorphism. and why this line over here illustrates dynamic binding. Before I tell you the answer, can anybody try? Let's start with the line first, the first one that's yellow. Okay? Why is this line polymorphism? Yes.
Because the states, the index at the states array is of a different type than like the states array is.
You're getting somewhere. You're getting there. Yes, very close. But somehow your use of term is not exactly right. Okay, getting there. Very good. What? Okay, let me start with that. The current state, yes. What's the static type for current states? States. Static type, states. Okay, continue. Exactly, yeah. Exactly. Okay, let me rephrase a little bit. Okay, basically the static type of current state is states. That means on the right hand side, any descendant class of state will be okay. And you can see states array I, the states array itself is also polymorphic. Statically state. Dynamically it can be initial, flight inquiry, and etc. Right? So that means it can give you some dynamic type that's appropriate. Okay, that's a polymorphism. Polymorphism simply means when you try to do this assignment here, current state will be assigned to some proper dynamic type. That's a descendant class of the states. That's polymorphism. Okay, now let's continue with the story here. Can somebody else try to explain why this line over here, current state dot execute, would illustrate dynamic binding? Let me try this. Yes, please.
So because state has different descendant classes of
State has different descendant classes. I agree.
Yeah,
Mm-hmm.
descendant classes of state.
Mm-hmm.
Current state has sorry, what am I for?
Take your time. That's okay.
Not deferred execute, but it had
Okay, first of all, how many versions of execute do we have?
one.
One, which is in the state class, right? However, under the execute, we got display, we got message, which are deferred.
Yes.
So which version of those features will be called?
It would be called according to dynamic type of
Current states.
current state.
Exactly right. Okay, good. Let me just repeat that very quickly. So now over here, when you see this line over here, you can see the execute over here. Okay, let me use a proper pen. The execute over here actually comes from the state class, right? There's only a single version. However, this in the execute itself, again, is a template, right? You can you can review that part. The template, for example, is going to refer to, for example, display. It's going to refer to message, etc. But now, which version of display and which version of message will be called depends on the dynamic type of the current states. If the dynamic type happens to be flight inquiry, in that case, the display you will call comes from flight inquiry, right? If the dynamic type is actually, let's say, reservation, in that case, the display comes from there, right? That's dynamic binding. Question?
Why is that polymorphism? Because the right-hand side returns state.
Mm-hmm.
Static.
Okay.
In the right-hand side, it's static.
Yeah. Yeah, basically, okay, let me just write it out, and then I see what you meant. So let's say you're talking about this line here, right? So I'll write it out. Current states is assigned to the states of index. Good. Okay. Basically, polymorphism simply means every time you're trying to do some assignments, and if the assignment itself involves some certain hierarchy of inheritance, then you have polymorphism. Okay. So now, in this case, current states over here, we know that its static type is simply states. Okay. So now the states over here, what's the static type for states at index? I agree. That's also states because you can see from here, right? Statically. Statically, we know that the state over here is a descendant class of states because the class is descendant of itself. So that's polymorphism. So that's allowed. Yeah, that's okay. But dynamically, we know that this array itself is also polymorphic. So that means dynamically the array might store different objects at different indices. So that's why you'll be reassigned properly. It's also polymorphic. Basically, polymorphic is simply when you try to do some substitution, like assignments. You can substitute certain things by its descendant classes, including itself. Yes. The from until loop. You can think about the loop over here simply tells you that you're going to keep interacting with the user until they are done with the process, right? That's why you're using a loop. That's why it's interactive. Good. Okay, guys, I know I'm running out of time. Give me 30 seconds. I'm going to finish that lecture, okay? Bear with me. Okay, that's about the application over here. And then there's a loop we just talked about. Okay, so this slide here summarizes everything you should know if you want to be the clients for the state pattern. Okay, I'll leave that to you. Everything has been explained. One more thing, the final slides. When you review the state pattern, start with these slides. This slide here basically compare the top-down hierarchical design, which is not OO, where you have to say display, for example, and then you got to take the current state as an integer. That's what you're going to do. You're going to pass around the current state always. On the other hand, if you do the OO solution, you want to ask yourself why OO with an inheritance hierarchy, which means polymorphism and dynamic binding counts for free. Why would that help, right? The final outcome is going to be like this. So you got basically here, I declare S of type states rather than integer, right? And then when I say S.display, here, depending on what the dynamic type is for S, is going to execute the correct version of display. Okay? Any question for this? Okay, that's good. So I will see you on Thursday.